Good evening, class. Every single Please. That is why I'm asking you to come here. Come here. You have your volume or something? Then you come for a party or what?
No, I
Then
actually went to my concert, but
sit here. You have missed. Who has missed some classes? She has missed. You have missed, no? Shiv, all of you have your textbooks, notebooks, everything. I want everybody to be independent. He will manage, don't worry. You don't have to worry about it. You to finish your discussion. Finish. Last time we were discussing about what? What did we speak about in class? What was it about? Yes. What is this rule called? Fleming. Yes. This is your Fleming left hand rule. Okay. What is important here? What do these three fingers indicate? What is the acronym that you should remember? I told you. Force. F. B. I. Yes, you remember as FBI. F is standing for force. It is the force with which the conductor is going to move. B is for. B is what? Direction of magnetic field. Write down. If you do not know what is B.
So B direction of magnetic field.
Yes, because B is the alphabet, which is different. Okay, B is the direction. You don't want to write also? Come on, write down. B is the direction of the magnetic field. And what is I?
Current.
Don't say just that current. It shows the direction because all of them are showing the directions. Have you followed? Okay, it is showing the direction of the current. If you are just writing current, I am not going to give you any marks. Please. It is going to indicate the direction. Right. What is it? What else is important? How about these three fingers? What is the condition here? Ufran, what is my question? What is the condition for these three fingers?
They should be perpendicular.
Mutually perpendicular, correct. What did we learn? They are not like this, right? They are mutually perpendicular. What does it mean? That your F is perpendicular to B, F is also perpendicular to I. Okay, they are all mutually perpendicular. So what are the three words that you must remember when you are writing the law? You have to stretch the three fingers of your which hand? Left hand. Just don't write stretch the three fingers. No marks given. You see, when I'm discussing itself, I'm telling you how many ways you can lose out points if you don't write the right words. So what will you say? Stretch the three fingers. What are the three fingers? Your thumb, index and the middle finger, okay, of the left hand such that they are mutually perpendicular to each other. What does the thumb indicate? What does the thumb indicate? Motion. Force. Force of what? Force of, no, not anything. Force with which the conductor is moving. What is this now? B. B is indicating what? Very good. So it is indicating the direction of the magnetic field. What does I indicate? Direction of the current. Did you understand? Okay. Please make a note of it. It is the direction. So also the, okay. Now we have also discussed that when is the force going to be maximum? Tell me. When is the force going to be maximum?
By increasing the strength of the magnet.
Also,
By increasing the electric current.
what else? Also, when these two are perpendicular to each other, if these two are not perpendicular to each other, there will still be some force. But the maximum force will be felt only when these two are perpendicular to each other. Did you all follow that part? Okay. Last time we have also seen this experiment. Activity 12.7. So Fran, I don't want you to be engaging. Rudra, why don't you pay attention to what's happening? Please, Rudra, pay attention. Okay. Look at activity 12.7. Okay. What is providing the magnetic field here? What are the two magnetic fields? What is it using? Listen to my question. Look at the activity which is 12.7. What is the magnetic field you do? Looking at the diagram, you can make out that there is a magnetic field somewhere. Where is it? It is due to what? Come on. Mera, come on. Hey, yes, what type of a magnet is that? It's a horseshoe magnet. In a horseshoe magnet, what do we have? You have the north and south. The magnetic field is from where to where? Always from north to south. Assume that this is north, this is south. It is always in this direction. Suppose I keep it like this, from north to south. If I keep it like this, from north to south, it's always in the same direction. Whatever way we are moving the horseshoe direction, horseshoe magnet. Is that okay? Did you all understand? Okay, so that's one magnetic field. Where is the other magnetic field? Look at the diagram and tell me. Inside the magnet? No. Where else are you getting? Around it? There's no solenoid, but you're coming very close to it. Yes, come on, Leela. What's happening there? I'm talking about 12.7. I'm talking about 12.7. I don't know whose pen it is. Somebody has left the pen. But I'm just using it.
Nobody knows that.
This is your magnetic field. What is this? This. See the diagram. What is it? It is an aluminium rod. Does it have a magnetic field?
Yes.
Why? Or why? Yes or no? It does not have. But I'm saying it will have. Why? Yes. When current is passing through this aluminium wire, obviously it develops a magnetic field. Okay? It is because there is a magnetic field around this part, around this aluminium wire, and there's also a magnetic field in the horseshoe from the north to the south direction, that there's going to be a force of repulsion. Do you see that? So the experiment that we were discussing about in year 12.7 is the force with which this particular conductor is going to be pushed away. because of the force or because there's an interaction between this magnetic field as well as a magnetic field here. Did you get it? Okay. So when you're asking why is there a motion here? Why is there a force? What force is actually pushing it away? It is the magnetic force here, magnetic force applying here, as well as a magnetic force here. That is going to be a force. Did you get it? There's going to be a repulsion. That is why we say it is F and a P and a I. So the direction of the force with which the conductor is going to be pushed away depends upon the direction of your magnetic field. It also depends upon the direction of the current. Is that okay? Did you understand? Yes? These are the two things that we know. What do we know? We know the direction of the magnetic field because we know how we are keeping the torsion magnet. We know the direction of I. How can we make out the direction of I? The way we have connected the wires. The wire which is connected to the positive terminal and another wire is connected to the negative terminal. So how will the current flow from where to where? From positive to negative, correct? So I know these two. If I know the direction of the magnetic field of the bar magnet, I'm also and I also know the direction of the current, then I will be able to find out the direction of the force. Have you followed? Be careful in the way you are writing that statement. Start with this, therefore you will come to know about this. Did you understand? All of you look at the Fleming's left hand rule again. Did you get it? Okay. The three directions, somewhere here in the middle of the paragraph, if you are paying attention, three directions can be illustrated by a simple rule called as the Fleming's left hand rule. Is it the thumb rule? No, it is the left hand rule. And use the word Fleming. According to the rule, you are going to stretch the thumb, the forefinger and the middle finger of your left hand. Did you notice the words that they are using? Underline the word of the left hand. You must write it, otherwise you will not be getting marks. Okay? And that they are mutually perpendicular. Use that word. That they are mutually perpendicular to each other. Then if the first finger points, so what is the first thing that they are writing? They are talking about this finger. If the first finger points, then we are talking about the second finger. Then we will come to know about the thumb. Okay, always talk in the same order, don't change the order. So, coming back, if the first finger points in the direction of the magnetic field, and if the second finger is in the direction of the current, then the thumb will. Do you understand how to write? Did you get it? Okay, got it? Right, fine. Okay, so and we have also discussed the various other current carrying conductors, like for example loudspeaker, microphones, everything makes use of it. Okay, electromagnet. Okay. Now, there was another thing that I was telling you last time is regarding the direction of the magnetic, the current. This is your positive and this is your negative. Correct? I'm not drawing the other things. Maybe you have a resistor here, you will have an ammeter, you will have a key, etc. For you to understand the direction of the flow of current. Conventional flow of current is from where to where? It is always from positive to negative. So it is flowing in this direction. Okay? But yes.
Normally, is there any specific that the resistor will be on the
Not necessary. Resistor can be here, anywhere. As long as it is in series, it's perfect. Gupran, you had it down. What was it?
Yes, ma'am.
Yeah.
Ma'am, in the textbook they have mentioned this about like this diagram. So they aren't mutually perpendicular.
Obviously, it is not possible. How can you show this direction? This is X dash, this is Y, and the Z will be here. It's impossible for us to show here in a textbook.
Yes, sir. Acha, okay.
So this is how it is going to be. How will you show this?
This one is standing up now.
See, like this. Did you understand now? Okay, so in many of the textbooks, they will also show a dotted line. Dotted line to show you this. Got it? All of you got this? Now coming back to this diagram.
So this one, the current is standing upwards.
Either which way, you can show in any which way as long as they're not, mutually perpendicular to each other. Now, we have seen that current is always from positive to negative, correct? But the flow of electrons, not the direction,
Negative to positive.
is going to be the opposite direction. Please remember this when we are talking about flow of electron or the flow of the conventional current. Instead of writing the flow of conventional current, what else can we say? It can also be said as the positive charge. Okay, so whenever they give you it is a positive charge, remember that it is going to be the current. Okay, now there's a small question there in your text. There's an in-text question. No, example 12.2. You need to pay attention to that. And they've also given you the direction, the magnetic field. How is the direction of the magnetic field? They have given the magnetic field is here. And you have the electron which is moving in this direction. Okay? An electron enters the magnetic field at right angles. That is already given, it is shown in the diagram also. The direction of the force acting on the electron will be how? What do you understand by this? What are they asking? What is the question asking?
And just one quick.
Sure.
Ma'am, is the direction of flow of force acting on electron with respect to us or with respect to the electron?
First of all, to read the question, what is being asked? What is given and what is being asked?
Direction of force.
So in these three fingers, which is the force?
Index finger.
Right?
Sorry.
This is what we do not know. Force is not known to us. Okay? Do I know the magnetic field?
Yes.
I know the magnetic field, which is the direction of the magnetic field. It is this one. I know it is like this. Okay? Do we know the direction of the electron?
Yes.
Yes. But electron is what? It is opposite in direction of that of the current. If the electron is like this, our direction of the current is going to be in the opposite direction. Yes. So how is the force going to be? So your F is here. Okay. F, I is what? It is in the upward direction. Right? It is in upward direction. And therefore you will have the force which is coming into the page. It's coming down like this.
I did not understand.
Look at the diagram. Look at the diagram. Yes, current is in the upward direction. F, B, I. Okay, here how is it? Magnetic field is here. And your electron, this is in the upward direction. Automatically your thumb will come down. I'll stand in this direction. You are seeing the mirror image. I'm standing like this and yours. Okay, F, B, I. Keep it. Magnetic field, which direction? As electron. First fix the magnetic field. Current कैसे जा रहा है? Current is like this, but it has to go up because now we are talking about electron coming down. ये हो गया ऊपर. Automatically हम कहाँ आ गया? Electron कैसे आ रहा है? ऐसे electron नीचे आ गया. Current ऊपर जा रहा है. अरे ऐसे electron is in the opposite direction of that color. Current ऊपर जाएगा. ये ऊपर गया. So ये सामने गया. Magnetic force. This will go here. ये नीचे आ गया.
This is indicated downward. So this is the
Please understand. How many of you did not understand? Oh my God. Girls understand? Once more. See, I am facing in the same direction. I am not even standing across you, right? First fix the magnetic field. Guessing here? Yes, you okay? All of you are okay with this? Magnetic field is here. The electron is going down. That means the current is going up. ये हो गया आपका current. Current कैसे जाएगा? ऊपर जाएगा. तो हम कहाँ गया? हम गया नीचे.
ऐसा ऐसा है ना, इलेक्ट्रॉन नीचे जा रहा है तो ये ऐसा कुछ हो सकता है.
Current See,
First it's like this is going in this way. If the electron is going down, current has to be in opposite direction. So it cannot be like this, right?
push it up that way.
It is how
You are showing the direction like this. This has to remain like this.
I know current इधर हो ये कुछ
Coming down. So the mode is acting in the pitch. Okay. I'll give you a few more questions so that you understand. Is it mutually perpendicular? Yours is not mutually perpendicular. Keep it as mutually perpendicular.
You want it like this way, right? It should be like in this way, and the current should be normal. So this, we want this to be like this,
Okay. 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 We'll give you okay. Done. Yes. Fine. So we'll give a couple of more examples of such type of examples where they say the electron is flowing towards you, it is going away from you, right? So you will understand how to do using your left hand with the 3 fingers in order to find out. Are you okay? Okay? Not yet. I'll give you some more examples.
You said we have to put the force down, right? Electron is still moving down. Electron is going down. The current is there. The current should be opposite direction. The electron is going down. It should be in upward direction. Like this. It's not in upward direction. It's upward direction. So the force will be in this way.
Wait, I'll show you. Okay, come on. We'll go. We'll continue and I'll give you a few more examples. Now, there's a small box which tells us about, are we here? Boys, girls? Magnetism in medicine. Same. Now, many of you must have heard about MRI, magnetic resonance and imaging. Basically, what happens is, sometimes what happens is, suppose a person is suspecting that some part of the human body is having some kind of a problem. That's when the doctor will recommend that you go in for an MRI. Okay, that's a scan basically. Okay, so when we are talking about a current carrying conductor and how it develops a magnetic field, that is what we have seen. And in biology class, you have also learned about neuron. What does a nerve cell do? A nerve cell is the one which is conducting impulses. So these are very weak electrical signals. But however weak it is, it develops a very weak magnetic field around it. So what we are actually doing in an MRI is trying to capture and enhance the magnetic field around. And especially for these two organs, we are talking about the brain as well as the heart. which has got a significant amount of the magnetic field around it. So if there's some kind of a problem, for example, if there's a suspected tumor, or if there's suspected that there is some kind of a blockage of the blood or whatever it is, by using an MRI scan, you can easily make out, okay, even before a person is actually going in for a surgery, what could be the problem. Have you followed? So once again, there is physics involved in this. And what is the basics of it? It is nothing but whenever you are having a flow of electricity, whether it is actual flow of electricity or probably as in the case of a neuron or a nerve cell, we are finding that there is a flow of charges. And because of the flow of charges, because of the flow of charges, what is happening? There is a weak magnetic field. Okay? And when a person is subjected to an MRI, so it catches and it magnifies and it feeds this information into the computer screen, and a 3D image is formed on the screen like this, and the doctors and the surgeons can of course see what is wrong, and that is how the treatment is being done. Okay, so let's have a look at the magnetism in medicine, how we can actually make use of magnetism in medicine. Who wants to read on this side? Will read? Virat, Tamani. Read.
An electric current always produces a magnetic field. Even weak ion currents that travel along the nerve cells in the body produce magnetic field.
And underline this. Weak ion. Okay, we are talking about current. And what is this current due to? The movement of charges. These are the charges which are present in the human body.
When we touch something, our nerves carry an electric impulse to the muscle beneath the nerve. This impulse produces a temporary magnetic field. These fields are very weak and are about 1 millionth of the Earth's magnetic field. Two main organs in the human body where the magnetic field produces significant are the heart and the brain. The magnetic field inside the body forms the basis of obtaining the image of different body parts.
So what is it that is important here? Why is it that we are getting an image of the organs of the body? It is because of the presence of a magnetic field. Underline that. It is because of the presence of a magnetic field that you are able to produce an image. Yeah, read further. This is done.
This is done using a technique called magnetic resonance imaging (MRI). Analysis of these images helps in medical diagnosis. Magnetism has thus got important use in medicine.
Yeah. Okay. So with this, basically, we are done with talking about how electricity produces a magnetic field, etc. Now, in the newer textbooks, one more part of it which we had was regarding the right hand Fleming rule. Okay, and about induction currents. All that has been scratched off. That's all been omitted. Unfortunately, I don't know why NCRT portion is getting reduced. They have cancelled out with periodic table, they have cancelled out. So it's only a part of the information that you're learning before you go on to the 11th standard. But once you come to the 11th standard, you're expected to know all these things. We will definitely, obviously, when you're going for your NEET or you're going for your IIT JEE, this is what you're expected to know. Better learn, better take the old textbooks, see what was the portion and learn it up. It's going to be useful. Okay, now we are also going to be talking about the domestic circuits. Okay, so basically when we know that the electricity which is produced is obviously produced at your power stations, right? It may be a hydro power station or it may be a thermal power station. From there the electricity is being supplied to either the domestic, that means to the houses, or maybe some part of it will also go into the industries. So the amount of current that is being supplied is obviously going to be slightly different. But there are certain safety precautions that you need to take. One, of course, all of you know, is regarding the coating of the wire. Okay, nobody touches a bare wire. Obviously, because the human body is a very good conductor. So always a wire has got an external outer plastic covering. So what is that thing made of?
Plastic.
What is it called?
Rubber thing.
I've given you that. It has come in your this in your chemistry.
अरे
What is
POP.
it?
नहीं POP कहाँ से?
PVC.
B.
VC.
PVC wire.
Ah.
PVC.
So the P stands for poly. Polyvinyl, polythene. Okay, so such type of material is usually coated on the wire so that there is no electric shock. Second thing, we have also learned about the fuse wire. Where did you come across a fuse wire?
CD.
In
CB.
fuse. Okay, we have talked about in the previous chapter. Previous chapter itself, we have seen that the fuse wire itself is made up of a wire which has got a very low melting point. So it is based on the heating effect of electricity. Yeah, which is an alloy, usually a alloy of lead and tin, which has got a very low melting point. So if there's an excessive amount of current which is going through, this will melt. And once it melts, obviously, there's no current which is supplied. Okay. So now we are going to see if you have seen
Even
it.
that electric circuit is now unusable.
Yeah, it has to be changed. Okay. Basically, I don't know whether you people have seen this type. Any wire, okay, we have 3 more wires inside. So the outer one is your PVC, correct? And each one of them has got a specific color, right? The green one is the earth wire, right? You may have a brown one and you may have a blue which is neutral. Correct, it may be slightly different. Yellow you would have seen. Yes, you would have probably seen a yellow one, but each one has got. The whole thing is covered with a white. Okay, so if you open it up inside, you will find those are the 3 wires. Now obviously this
Inside I have seen a yellow color.
even yellow color is for sometimes they use for so we have got those 3 pins. We call it as a 3-pin plug, which fits into a 3-pin socket. Right? So the one which is right on the top, this is your earth wire. This is where your earth goes in. Okay? So earthing is also another method to protect the appliance from any type of a electric shock. So basically try to remember these colors. Earth is usually green, live is either red or brown, okay, and neutral is either blue or even black in color. So the potential difference between your neutral as well as a wire, live wire, is about 220 volts, and that is what we are getting now. Potential difference between the brown and the blue, okay, between the live wire as well as the neutral wire is about 220 volts. Okay. In different countries, it's slightly different, but it is for the domestic supply. But when we are talking about, let us say, industrial supply, they require more current. Okay, so obviously the potential difference will be slightly different. Now here again, what we are interested in is regarding the earth wire. Okay, we usually see that there's an earth wire which is fixed onto the appliance. For example, if you are using a hot iron or whatever it is, imagine that this is an iron. Okay, you have got a cord and this cord will be going into the plug. Have you followed? So even by chance, if a person is touching the metallic part of the body, he does not get a shock. And that is because of this earth wire. So what happens in the earth wire is, let us say they want to make a house or a building or whatever it is. They are going to make a foundation. That means they are going to dig deep inside the earth. Okay. So by digging deep inside, okay, they are going to put a wire which is fixed to a copper plate. There's a copper plate which is buried deep inside, and this wire is actually the earth wire. And all the electrical appliances are connected to this earth wire which is supplied to each and every socket wherever you are having. So when you are having your 3-pin point and you're fixing it into the plug, that is into the 3-pin plug, you have the earth one which is connected here. So even if there's some kind of a current leakage, the person is safe and the current is going to the earth. Is that okay? So there's a very small video regarding how they're actually making the Did you see that now? Did you see? That's your 3-pin plug point. Okay. So you're going to put the earth that comes right on the top. Then you have your phase wire. Phase wire is nothing but a line. And of course that is your. Sorry.
I'm discussing an exam as well.
Which one? It's given. We are going to discuss now. Okay. This is just to give you an idea regarding how actually earth wire is being made. Okay, now first of all, we are going to dig a deep hole into the earth, and you are going to take a wire, a tube like that, fix it inside. See now? Did you see that? I'm going to do a little bit of fast forward. Now they're putting salt inside. That's for having a greater conductivity. Then they're also going to put a little bit of charcoal. Once again, the same, basically to make sure that the pit is actually filled. Then of course they're going to fill it up with.
Why did they put charcoal in there? Coal, sorry.
Yeah.
Why did they put it?
Yeah, basically to help the conductivity. See that? Now see, what are they doing? They're taking out the outer casing of the wire, and the copper wire is being connected to this. You see that? So that is your earthing. Do you understand? So every building, irrespective of where it is, will have an earth. And all your electrical appliances are connected to this earth wire. Got it? Especially if you see. That's your earth. Nothing will happen to it. Just to give you an idea regarding how actually earth wire is being made.
Why did short circuit?
Yeah.
Why did it happen?
Help it to settle down. Both thing has to be packed. It's not simple. It's only sand, it's only coal, and then a bit of salt.
Where did he put the wire?
You connected it to the tube. The entire tube.
Can he put water inside the tube?
All around outside.
So
Back it.
Nothing will happen.
Nothing will happen. Because there's no current as such. It is only helping for the passage of the current. If there is a leak, it will help it to the There's no current. Sorry?
Solenoid video.
Video. I have to show.
Yes,
I have
ma'am.
shown you already.
No, ma'am.
Okay, I'll see it again.
Ma'am, chapters.
Almost ending, but we'll do a lot of questions. Domestic electrical. How is earth different from? It is only made up of copper. Even the other ones are also made up of, but there is no electricity flowing in the earth wire. If there is a leakage of current, then it will go into the earth. No, nothing else. Domestic earth circuit. In your book. Hello. Different. Read.
In our homes, we receive supply of electric power through
We
a
read
main
first and
supply,
then I make it.
through a main supply, also called mains. Either supported through overhead electric poles or by
Overhead.
overhead electric poles or by underground cables. One of the wires in this supply, usually with black insulation, is called neutral wire or negative. In the country,
Red insulation. The line above. Read that sentence again.
one of the wires in this supply usually with red achar ke साथ. Red insulation cover is called live wire or positive. Another wire with black insulation is called neutral wire or negative. In our country, the potential difference between the two is 220 volts.
Did you underline all these? Simple questions can be asked regarding what is a blue, what is a black wire indicate, what is the potential difference between these two. Hello, did you underline?
At the meter board in the house, these wires pass into an electrical meter through a main fuse. Through the main switch, they are connected to the line wires in the house. These wires supply electricity to separate circuits within the house. Often, two separate circuits are used. One of 15 ampere current rating for appliances with higher power ratings such as geysers, air coolers, etc. The other circuit is of 5 ampere rating for usually connected to a metal plate deep in the earth near the house. This is used as a safety measure, especially for those appliances that have a metallic body, for example, electric press, toaster, table fan, refrigerator, etc. The metallic body is connected to the earth wire, which provides a low resistance conducting path for the current. Thus, it ensures that any leakage of the current to the metallic body of the appliance keeps its potential to that of the earth, and the user may not get a severe electric shock.
Okay, so there are two lines which is supplied. You obviously realize that all the gadgets in the house will not draw the same amount of current. Suppose you have a fan or a bulb, and on the other hand you have a geyser, which will draw in more current. Okay, oven or a geyser is going to draw in more current, so that has to be supplied with a 15 amp current. Okay, whereas the other one is for low amount of current, which is going to be 5 amp current. So based on whatever is required for whichever appliance, that type of a, okay. You will also notice in your house some of them, these type of plugs, or some of them are smaller ones. But for things like your geyser or for your refrigerator, you have those 3-pin points which are slightly larger. So that is calling a 15 amp current. Okay, so look around, you will understand some of them are for 5 amp and some of them are for 15 amp current. Is that okay here? Okay. Next one, the diagram there, it is going to give you a schematic idea regarding how the electric supplied the house. Try to remember from what we have done in the previous lesson. How are the appliances connected? Is it connected in series or in parallel?
Appliances.
How are they connected? In parallel. What is the idea of connecting them in parallel?
Because different appliances get equal amount of.
Different appliances will take different amount of
हाँ हाँ एक खराब हो गया तो दूसरे पे इफेक्ट.
Yes, so how will you put it in your answer? Every appliance requires a different amount of current. Okay, but what is, remember what happens in a parallel connection? You have got resistant 1, R1, R2 and R3. All the three of them are connected here. So what is common for parallel? Can you remember the diagram what I am talking? Are you remembering the diagram that we are talking now?
Yes.
In series, we have got 3 resistors like this. Okay, but in a parallel, what happens? This is parallel connection, such that the current which is flowing through each one of them is different. Current here, and current here will be different depending upon the resistor. Okay, but what is common here? What is common in here?
potential.
Correct. So it's a common potential difference is common for each one of the appliances. Okay. Now my question, coming back to my question, how are the appliances connected at home? How are they connected? It's always connected in parallel. Why is it connected in parallel? Well, come on, tell me. Some answer at least you can give me now. Shh. I can hear you. Come on, you can also hear. Come on. Tell me fast. Suppose this is your TV, okay, this is your fridge, and this is your oven. I'm giving you examples also. Come on, tell me. Why is it connected in parallel?
अगर एक बंद होने से दूसरा
Come on,
डिफरेंट
yeah.
इंस्टेंसेस.
Tell me properly.
And if one appliance gets turned off,
Translate from Hindi to English. Come on, tell me. So what happens? Let us say this is count off. Then will work because why? Because it has got different paths for the current.
if one appliance gets turned off, the other appliance will not be
Yes, will still be working.
That's why in a house there are many MCBs.
MCP is different. MCP is your what? Is your current which is going to, if at all there's a surge of current, it has to stop immediately.
I'm not playing the main one. Like there are many MCBs for a many.
Yes, yes. That is also a safety precaution. So that even if some of the appliances get spoiled, something else doesn't get burnt out. Okay. So we come to the paragraph where we are talking about this diagram. Okay. Carefully look at the diagram. Shh. Carefully look at the diagram there. What do you notice? Did you notice a green wire coming from the left? That's your earth wire. There's a red wire coming up. That's a light. And there's a neutral wire. Okay. But notice how the earth wire is connected to the appliances here. Is it going through the electricity board? The green wire is not going through the electricity board. Okay, so the earth wire is not supplied by the electricity board. Why? Who is going to supply the electricity board? The green wire? Sorry. How is it? How is it? It is only the building which is going to supply the earth wire. Have you followed? Why is it taken up? Obviously, because it is a safety device. Okay. Next, I want you to see these three things. What does it indicate? What are those three things? It is indicating the lamps or the different appliances. That way. Those three things. Okay, suppose there are three of them. Suppose there are three of them. What does this 220 indicate?
potential difference.
Potential difference between what and what?
Red and black wire,
What is it?
live and
Okay. So the potential difference between your live and neutral is your 220 volts. Okay. Did you notice that the green wire is not there? It is supplied from outside. Okay, supplied to each one of these appliances. Okay. It gives a schematic diagram of one of the common domestic circuits. Gufran, what is happening there? Look at the book in front of you. Look
in
at
my
the book.
book now, it's shading on this. It's not visible clearly. So that's why
In each separate circuit, different appliances can be connected across the live and neutral. Shh. Each appliance has a separate switch to switch it on and off, in order that each appliance has an equal potential difference. Underline. There are certain words that I am stressing. I expect you to use those in the answer. Equal potential difference. That is why they are connected in parallel to each other. Did you get it?
Yes.
Next, of course, we have already discussed regarding the electric fuse, which is an important component. Okay. What is the principle of the electric fuse? What is it based on? Class, I'm asking you a question. What is the electric fuse based on? What is the theory behind that?
heating.
What is happening to electric fuse? And how is it connected? Is it connected in parallel or it is connected in series? Remember, it has to be in series. That means current has to come, pass through the fuse, and then only go into the house. Okay. So what type of melting point? High melting or low melting?
Low melting
point. What happens if there's a surge of current? It melts, and obviously everything stops, and therefore the appliances being saved. Okay. Yeah. Leave. That paragraph. Electric fuse.
Electric fuse is an important component of all these circuits. We have already studied the principle of working of a fuse in previous class. Section 11.3.7. A fuse in a circuit prevents damage to the appliance and circuit due to the overloading. Overloading can occur when the live wire and neutral wire come in direct contact. This
1 minute. Underline the word overloading. Okay. Like I have already shown you in this diagram, your earth wire, your live wire, and neutral wire, there are 3 separate wires. And each one of them has got a different coating. Okay. But in the sentence here that they have given, what is overloading? Leave.
Live wire and the neutral wire.
What does that mean?
Coming to direct contact.
Yes. Okay. If this live wire and the neutral wire is somehow coming in contact with each other. Okay. When does it happen? When the outer casing becomes brittle, or when the wires have become very old, this outer casing has come loose or whatever it is. Only then this live wire and the neutral wire, if they come in contact with each other, it can cause a condition called overloading. That means it's getting heated up there. Right, continue.
Suppose the installation of wire is rapid or there is a fault in the appliance. In such situation, the current in the circuit abruptly increases. This is called a short circuit. The use of an electric fuse prevents the electric circuit and the appliances from the possible damage by stopping the flow of unduly high electric current.
Unduly high current.
Unduly high current. The joule heating that takes place, the fuse melts it to break the current electric circuit. Overloading can also occur due to the accidental high in the supply voltage. Sometimes overloading is caused by connecting too many appliances to a single socket.
Okay. So when you are having many appliances, maybe you have switched on the oven, you have switched on the fridge, everything to the same socket. Obviously, it is drawing in a lot of current. Okay. So that is when it can actually cause a condition.
Why does it keep any glass or metal microphone?
What is basically microwave? What does it make use of? Is it heating? Substance is getting heated up, but are we actually using a coil to heat up? You are using this word called microwave. So what is happening there? Effect of coil. You are coming closer. Yes, you are coming.
Your question.
I'm talking about in a microwave or a micro oven. How does it basically work?
Something yellow you
Ma'am, there is the wire. Ma'am, the wire has high resistance. So it affects heating. Let's keep it.
Okay, I hope you remember something about the electromagnetic spectrum. The visible UV you have got the X-rays, you got the gamma rays. And at the higher frequency, basically what do you have? You have your IR. IR is what? Infrared. And then of course you have got your radio waves and you have got your microwaves. So when you are talking about heating up of food substances, we are not using anything that is causing heating. Any substance which has got water, moisture, obviously has got water molecules. Okay? So we want those water molecules to agitate. So the more it is agitating, so because of which it produces kinetic energy and that is a causing a heating effect. You understand? So we are making use of the microwaves here. Making use of the microwaves to agitate the water.
Everything microwave to heat up the substance is microwave.
Do in a micro oven. Oven.
glass or something keep metal in it.
No, you cannot use a metal because it has to be only ceramic or glass or certain substances which is microwave safe.
Right.
But why does it break? Like why does it?
Does it?
ज्यादा heat purpose देंगे.
It does not. Ceramic
Ma'am,
will not.
Glass breaks, ma'am, in the
Glass
microwave.
cracks.
Glass
Depends
breaks.
if I charge if there is already a crack or something, otherwise it does not. 1 minute, Kaushik. If there is a glass appliance with a metallic sound kind of a design or something, then it happens. So that is why they are telling you to use ceramic or it has to be a micro safe glassware. It has to be a special type of a glassware which can withstand such type of. Okay, come on now. Quickly, in your notebooks, quickly. Almost time, but then come on. Just enough time. Come on. Write down the colors quickly. Okay. Colors of the wire. Live wire.
Red.
Flash brown.
Stick to whatever is given in the text. Live wire is red insulation. Then neutral is black. Slightly different.
Blue
Blue or black. We usually do blue or black. And the last one is green color, which is for earth. Last one is earth wire, which is green. Another commonly asked question is the potential difference. Take on the next point. Potential difference between live and neutral is dash 220 volts. Live and neutral. Okay. Next one. Next question. What is earthing? Earthing. I showed you now what is earthing. What is it? It's nothing but a safety device. Okay, so we are going to write down about that answer here. Last paragraph here. Okay. The earth wire is usually connected. First point. The earth wire is connected. Earth wire is connected to a metal plate. You don't want to write. To a metal plate deep in the earth. Near the house. Next point. This is a safety device. Especially for those appliances. This is a safety measure or safety device for those appliances that have a metallic body. That have a metallic body like what? Iron. Okay. Toaster, fridge, and
Especially for the
it's there in the textbook. You have the textbook, refer to the last paragraph. On page number 204. Next point. The metallic body is connected to the earth wire. Which provides a low resistance conducting path, low resistance conducting path for the current. And also this thing, path. Yes, conducting path for the current. There's one more line in your textbook, complete it. Yes. Don't forget, complete the answer. Complete it at home. Or you want to complete it now, that choice is yours. Remember to do it, okay? this week? Not use it, generally. People had an exam, test here. This week you had
Bio. Bio.
chemistry, physics,
Thank you, ma'am.
Thank you.
ये राखी साइन कर दे।
इधर दे ओए
कितना दिया उसने देखो
20 दिए हैं
1 रुपए का
ये दे अबे है ना इतने पे सजा के बैठी हो क्या
ये किसका क्लास है? ये किसका है?
वो किसका वो मेरा
चलो जाओ घर पे नहीं जाना है।
अरे जाना